Alright, if you guys could please turn to 12.5, volume of pyramids and cones. Alright, theorem 12.9, volume of a pyramid. The volume V of a pyramid is 1/3 base times height. Notice that the capital B is the area of the base, and H is the height. Now, the area of the base is going to change depending on what shape the base is. In this case, we have what looks to be a square or possibly a rectangle, but you can have a triangular base, you can have a pentagonal base. The example we're going to do has a, a hexagon for base. Alright? So for example 1, find the volume of a pyramid. Find the volume of the pyramid with the regular base. First, find the area of the base using the formula for the area of a regular polygon. Alright, this is the formula for a regular polygon. Okay? Hopefully you guys remember that A stands for the apothem, and the apothem is the distance from the center to the side. And they're nice enough to give you that the apothem, the distance from the center to the side, is 2√3. So the apothem A of the hexagon is 2√3 inches, and the perimeter P is 6, because there's 6 sides, times 4, because each side is 4 inches. So all the way around is 24 inches. So it's 1/2 A, which is 2√3, times 24. Okay, now half of 2 is just 1, so we're going to end up with 24√3 inches squared. That's the area of the base. So now we can just plug it in. We have 1/3 capital B, and we just found capital B. And the height, which is given to us up here. Okay? 1/3 of 24 is 8. 8 times 10 is 80, so we've got 80√3. Okay? Which is about, if I go and get my calculator, here it is, 80√3. So 138.56, approximately. 138.56 inches cubed. Okay? Remember, when you're dealing with volume, you're going to have cubic units. So the volume of the pyramid is about 138.56 cubic inches. Okay? Let's go on to page 2. 12.10, volume of a cone. The volume of a cone, V of a cone, is, same thing, 1/3 base times height. Now, in this case, we know that the base is a circle. Okay, so the base is going to be pi r squared. So instead of this, we could just write 1/3, instead of V, write pi r squared times h. Same thing, since we know that the base is a circle. Okay? Let's take a look here. You have a right cone here. Use the formula for the volume of a cone. V equals 1/3 pi r squared. We know that r is 9.5. Okay, and the height is 16.8. Alright, I pulled up my calculator again. 9.5 squared times 16.8. That gives us 16.2. Oh, I almost forgot to divide by 3. There we go. 505.4. 505.4 pi. If we multiply by pi, we get 1587.76. 1587 point, I already forgot what it is. 76, okay. Millimeters cubed. So the volume of the right cone is about 1,578.76 millimeters cubed. Okay, we're going to do the same thing for the next one. 1/3 pi r squared h. R in this case is 4.5. And the height is 12. Okay, pull out the calculator again. 4.5 squared times 12 divided by 3. We've got 81 pi, which is approximately 254.47. And this is feet cubed. So, the volume of the oblique cone is about 254.47 cubic feet. Alright, let's go on to page 3. Example 3. Use trigonometry to find the volume of the cone. Find the volume of the right cone. Okay, to find the radius r of the base, we need to use trigonometry. Alright, so in this case, we're given this angle, and we're given the height, but we don't know the radius. So, here's my theta. This is the opposite side. The side we're trying to find, r, that's the adjacent side. So if you think SOHCAHTOA, we're going to use tangent to find this. So, tangent of 62 degrees is opposite over adjacent. Tangent of 62 is going to be 12 over r. Okay? Now, if I multiply both sides by r, this goes away, and then I can divide both sides by tangent of 62. So 12 divided by tangent of 62 degrees. Alright, now we can pull out our calculator again. Alright, 12 divided by, actually, before we do that, let's make sure the mode is in degrees. There we go. Okay. Now we can go 12 divided by tangent of 62 degrees. Alright. 6.38. And this is meters. Okay. Now we can use the formula. 1/3 pi r is 6.38 and the height is 12. Let's pull out the calculator again. We've got 6.38 squared times 12 divided by 3 times pi. 511.51. Meters cubed. So the volume of the cone is about 511.51 cubic meters. Okay, find the volume of the composite solid. So this is what we want to do here. We have a cone on top and a cylinder on the bottom. We're going to want to find the volume of the cone and then the volume of the cylinder, and then add them together. So, as it says here, the volume of the solid is the volume of the cone plus the volume of the cylinder. Okay, and actually, they have it reversed here. This one is the volume of the cylinder, and this is the volume of the cone. But either way. Okay, so this, we're dealing with the cylinder here. So pi r squared, the radius of the cylinder is 3, and the height of the cylinder is 7, plus the volume of the cone. the radius of the cone, because it's attached to the cylinder, it also has to be 3. Has to be the same as what's down here. And the height is 3. So 3 squared is 9. 9 times 7 is 63. 3 squared is 9. 9 divided, 1/3 of 9 is 3. 3 times 3 is 9. So 63 plus 9, that gives us 72 pi centimeters cubed. Okay, so the volume, let's pull out the calculator. Here it is. 72 pi, 226.19 cubic centimeters. Alright? Okay, last page. Checkpoint. Find the volume of the solid. Round your answer to 2 decimal places. Okay, I want you guys to try the first two on your own. Go ahead and pause the video here, and once you think you have the answer, hit play. Alright, these are the answers you should have gotten for the first two. Go ahead and pause the video here if you need to look at the diagrams, look at the work, okay? Okay, last two. Go ahead and pause the video here, try these last two problems, and then when you think you have the answer, hit play. Alright, these are the answers you guys should have gotten, and that's all the notes for today. I will see you guys tomorrow.